we're going to show you the different types of sequence with the theme of sequences are the basis of series. At the end of this presentation, we will going to learn the different types of sequence, to know how to find missing terms along with special sequences like the Fibonacci sequence, and to work out whether a particular number appears in a sequence. In mathematics, a sequence is an enumerated collection of objects in which repetitions are allowed and order matters. Like I said, it contains members, or also called elements or terms. The number of elements, or possibly infinite, is called the length of the sequence. And like I said, the same elements can appear multiple times at different positions in a sequence, and then like I said, the order does matter.
Oh, so many patterns here. How are the patterns formed? What are the formulas or sequences used here? Ah, yeah. Let me search it on Google. Oh, there are 3 types of sequences: the arithmetic sequence, the geometric sequence, and the Fibonacci. Ah, okay. Let me ask my teacher on Monday about arithmetic sequence. Ma'am, I have a question.
Okay, Miss Paulinho, what is it?
What is arithmetic sequence?
Well, an arithmetic sequence is an ordered set of numbers that have a common difference between each consecutive term. For example, in arithmetic sequence 20, 40, 60, 80, 100, the common difference is 20. Gets? An arithmetic sequence can be known as an arithmetic progression.
Okay, ma'am. Thank you for explaining. Now I know what is arithmetic sequence.
Geometric sequence is one of the most important branches of mathematics as it is implemented in our day-to-day life. Geometry allows you to determine how shapes and figures fit together to maximize efficiency and virtual appeal. In daily life, we face a lot of practical situations where we need to calculate a certain distance between objects, calculate the size of shapes that need to be attached in a position for measurement, and much more. Now, I want to show you a scenario that talks about a geometrical sequence.
Oh no, I already forgot how to get the next term. Let me try to ask Redoble. I swear she knows it.
Hey, what's up?
I'm sorry to bother you, Redoble, but I need your help. Can you do me a favor, if it is okay?
Oh, sure, why not? So, what is your concern?
Redoble, can you teach me how to solve geometric sequences? Because I cannot get the second term and also the rest.
You didn't listen to our discussion last time, no? That's why you don't understand the topic. But don't worry, I'll give you a quick presentation about our discussion last time. Don't worry. Geometric sequence, a geometric progression, also known as a geometric sequence, is a sequence of non-zero numbers where each term after the first is found by multiplying the previous one by a fixed non-zero number called the common ratio. We can solve for any term of geometric sequence using the formula a sub n is equal to a sub 1 times the ratio raised to n minus 1, where a sub n is the last term, a sub 1 is the first term, r is the common ratio, and n is the number of term. We can also use this formula to solve real-life problems involving interest rate, the increase of population, bacteria, viruses, and many more. But we will focus on this increase of infectious diseases to save awareness to people so that they will realize viruses should not be taken for granted. Word problem number 1. Suppose that Barangay 4-A record its first 5 COVID-19 cases on day 1. If the number of persons infected with COVID-19 doubles each day, how many persons will be infected after 15 days? So, we know that in the first day, we have 5 COVID-19 cases. And knowing that it doubles each day, we have the common ratio of 2. And we want to know how many persons will be infected after 15 days. So using the formula a sub n is equal to a sub 1 times the ratio raised to n minus 1. So using the formula of geometric sequence, a sub n is equal to a sub 1 times the ratio raised to n minus 1. We have a sub 15 equals 5 times 5 raised to 15 minus 1. Then we have a sub 15 is equals to 15 times 2 raised to 14. Then we will find the value of 2 raised to 14, and that is 16,284. Then we multiply it by 15, that would be 32,768. So it means we will get 32,768 confirmed cases in just 15 days. So imagine how fast the virus is spread. People should not really take it lightly.
Thank you so much, Redoble, for explaining me about geometric sequences. So now I understand it clearly. Geometric sequences, you can also use into our daily life. When it comes to school, in homes, and also in work. Anything involving compound interest boils down to geometric series, like calculating the payment for a car mortgage or any loan in general, saving for retirement, or can deposit in a bank, interest during peering account. So everything digital is ultimately doing something with a sequence of 10% or 20%. It's depend upon to the deal.
Fibonacci sequence is very famous because it is the same pattern that is found in many natural wonders such as petals of flowers, shapes of eggs, and etc. This sequence is also used to determine the golden ratio, which is very important component in design and photography, the golden ratio between any two numbers of Fibonacci sequence. Fibonacci sequence discovered by Leonardo Pisano Buguglio, an Italian mathematician who discovered the sequence. His nickname was Fibonacci, which really means son of Bonacci.
Hello, Riza. Where are you now? Are you free? Let's go. Let's hang out.
Hello? At home? No, we can't hang out today because we have a lot of activities to do. We will pass it on tomorrow.
Ah, really? I'm sorry, I forgot. By the way, what is our topic?
Our topic is all about Fibonacci sequence. In our nature life, we need to give the example that represent about the Fibonacci sequence.
Okay, thank you, Riza, for reminding me. Oh my god, this is so cute. I like the color. I want to take a selfie.
One of the example of Fibonacci sequence is these flowers because it has 5 petals. 1, 2, 3, 4, 5. And Fibonacci sequence is 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. One of the most common and simple type of Fibonacci sequence that can be found in modern world life and nature. I'm so hungry. I want to eat boiled egg. Egg can also Fibonacci sequence. The shape of an egg, it follows the golden ratio. Since the spiral offers path of least resistance, it follows the offers the most protection.
The Fibonacci sequence appears in nature because it presents the structure and sequence that model physical reality we see it. In the spiral pattern of certain flowers because it inherently models a form of spiral. The Fibonacci sequence is a set of numbers that starts with a 1 or 0 followed by a 1 and proceed based on the rules, and each numbers called the Fibonacci numbers is equal to the sum of the preceding two numbers. Hi guys, so one of the example of Fibonacci sequence is this finger because it has 3 volts. 1, 2, 3. And the Fibonacci sequence is 1 plus 0 is 1. 1 plus 1 is 2. And 1 plus 2 is 3. As you can see, we have medicine here and it has 3 capsules, which is this 3 capsule, it's follow the rules of Fibonacci sequence. 1, 2, 3, 4, 5, 6, 7, 8. The other example is lemon. Lemon have a number in the Fibonacci sequence 8. The segment on the lemon is a part of the Fibonacci sequence.
I hope that you have enjoyed your exploration of the Fibonacci sequence. Now you see that math is very much all around you in everything you see and do, whether it be art, music, literature, architecture, or movies.